Hello everyone, my name is Anuja Shrivastava and I welcome you all in class 8 physics class. Today I will discuss the third part of second chapter physical quantities and measurement, and in this video we will study about the measurement of fluid, measurement of density of fluid. So I have written over there the fluid. So fluid, it contains both liquid and gas. That means we will study about the measurement of density of liquid as well as measurement of density of gas. So let's start the measurement of density of liquid, and this we can done with the help of two things. First is the graduated cylinder and second is the density bottle. The measurement of density of liquid by using measuring cylinder or graduated cylinder. So this is the graduated cylinder, and how we can measure the density of the liquid through this cylinder. So this is the empty cylinder, and before pouring the liquid we must know about its volume, and for volume we must know about the mass of the vessel. So that means the mass before pouring the liquid is equal to M1. Now pour the liquid whose density is to be measured. And after pouring the liquid whose density is measured, then again measure its mass, and it should be M2. And after pouring the liquid, the mass, let volume will be V. So we know the formula, that is the density is equal to mass by volume. So mass, we are having mass of liquid, is equal to M2 minus M1, so that the density of a liquid will be M2 minus M1 divided by V. And in this way we will measure the density of liquid by using the measuring or graduated cylinder. Now we can also measure the density of liquid by using the density bottle. This is density bottle. So how we can measure the density? This is a glass bottle, on that a cap stopper is there with a fine hole, and this fine hole is for that when we are going to pour the liquid, so excess liquid will rise up in this tube and that will be overflow. So how we will measure it? Again, for the mass, that means this is the clean and dry bottle, and if you want to measure the mass, so before pouring the liquid the mass will be M1. Now pour the liquid whose mass is to be measured. After pouring the liquid, the excess liquid will be overflow, then clean the bottle with the blotting paper and measure its mass, then the mass will be M2. And the volume after pouring the liquid, that means the volume of the density bottle, so volume will be V. And again the formula is same over here, density is equal to M2 minus M1 divided by V. In this way we can measure the density of density of liquid by using the density bottle as well as by using the graduated cylinder. Now let's measure the density of gas. So density of gas, so if we want to measure the density of gas, take a empty flask, and measure its mass is equal to m1. Now use vacuum pump and remove the air present in the flask, and then fill the gas whose density is to be measured. After filling the gas, the mass will be m2 and the volume is V. Now after that we are getting mass and volume, so apply the formula, the density is equal to mass, that means m2 minus m1 divided by V, and in this way we can measure the density of a gas. Now let's move toward the another topic, and that topic is the relative density. Relative density, which you can also denote with the RD. So this relative density, this is the density of any substance, any object which compare with the water, so that the relative density helps in the comparing of the things. So suppose, take one example, the relative density of iron. Relative density of iron is 7870 per cubic meter, and RD of water is 1000. So how we can measure the relative density of iron? So this is density. So the relative density, to find the relative density, divide density of iron by the density of water, and we get 7.8. There is no unit for the relative density. Now, so the another topic, that how we can measure the relative density. Measurement of relative density. For the measurement of relative density, we will use again the relative density bottle. Now, for the relative density, take a density bottle and measure its mass by using the beam balance, and so mass will be m1. Now pour the liquid whose density is to be measured, and the mass will be m2, and the volume is same as the volume of the bottle, so that here V. Now this is for the density of the substance whose mass is to be measured. Now for water, that means after measuring this, clean that bottle, and for water now going to take, so fill the water and again measure the mass. So the mass will be here m3, here m2, so the mass of liquid will be m2 minus m1. and here for water mass is equal to m3. So for mass of water is equal to m3 minus m1. Now how we can measure the density of the substance? That means RD of liquid so if you want to measure the RD of the liquid, so as you know, first we will measure the density of liquid. That means density of liquid divided by density of water. Now as we know, the density of liquid is over there, that means the m2 minus m1 divided by V, and density of water is m3 minus m1 divided by V. So volume is common for that, so for the density m2 minus m1 divided by m3 minus m1, and in this way we can measure the density of relative density of the liquid. Now quickly just see one more topic, that is float and sink. You are observing when you are putting iron nail in a glass of water, that iron nail is going to be sink, and when you are putting one cork, one wood in the water, that is going to float on the surface of the water. Why this happened? So this happened because if relative density of a substance is lighter, is lower than that of the water, that substance will be float, and if the relative density of an substance is higher than that of the water, that substance will float. Suppose you can take over here, suppose cork. The relative density of cork is 0.2. So cork is going to float on the water, and if we will discuss about the other substance whose density is higher, that substance is whose density is higher than that of water, that is going to sink, and whose relative density is lesser than compared to water, that is going to float on the surface of the water. Now rest of the topic we will discuss in the next video. Till then, bye bye, thank you.